students, welcome to Easy BTech channel. Today I am going to explain about one of the important theorem. That one is Taylor's theorem and application of Taylor's theorem also. So before going to explanation about Taylor's theorem and application of Taylor's theorem, please like, share and subscribe our Easy BTech channel. Let me explain about Taylor's theorem. So what is nothing but Taylor's theorem? The statement of Taylor's theorem is if f maps a comma b tends to R such that f maps a comma b tends to R such that f power n minus 1 x is continuous, f power n minus 1 is continuous on the given intervals, closed intervals on a comma b. And second condition, f power n minus 1 into x is derivable on open intervals of a comma b such that there exists one value theta belongs to open intervals of a comma b such that f of b is equal to f of a plus b minus a by 1 factorial f dash of a plus b minus a whole square by 2 factorial f double dash a and plus b minus a whole cubed by 3 factorial f triple dash a and so on, and plus b minus a whole power n minus 1 by n minus 1 factorial f power n minus 1 into a plus Rn. So this is nothing but the Taylor's theorem. So what is the statement, students? Taylor's theorem statements. If f maps a comma b tends to R such that if f power n minus 1 of x is continuous on closed intervals and it is derivable on a comma b, that means the open intervals, such that there exists one value where that value belongs to the open intervals of a comma b such that f of b is equal to f of a plus b minus a by 1 factorial into f dash of a plus b minus a whole square by 2 factorial into f double dash a and so on, and b minus a whole power n minus 1 by n minus 1 factorial f power n minus 1 into a plus Rn. So this f of b is known as the statement of the Taylor series or Taylor's theorem. So where here the value of Rn is known as remainder. Rn is known as remainder. So now the value of Rn, the remainder value is here b minus a whole power n by n factorial into f power n of theta. So here the value of Rn is known as a remainder, where the remainder value is b minus a whole power n by n factorial into f power n into theta. So please remember this formula, students, f of b formula, Taylor's series or Taylor's theorem formula. So here alternate form of Taylor's theorem. Alternate form of Taylor's theorem. So what is the alternate form of Taylor's theorem here? The alternate form is nothing but here. So put b is equal to a plus h in this above expansion, then b minus a is equal to h. Okay, students, b is equal to a plus h and b minus a is equal to h, and a less than or equal to x less than or equal to a plus h. And here in this f of b, You substitute all these values. That means f of, what is the value of b here? B substitution is a plus h and is equal to, and f of a is as it is and plus, and here b minus a is there here. See here, b minus a is there here. In the place of b minus a, substitute h here. H by 1 factorial into f dash of a, and similarly b minus a whole square is nothing but h square by 2 factorial into f double dash a. In the place of b minus a whole cubed, h cubed by 3 factorial into f triple dash of a, and so on. And the last term b minus a b minus a power n minus 1 is there here. Then h power n minus 1 by n minus 1 factorial into f power n minus 1 into a, and plus the last term is Rn. And here also Rn is known as remainder only. Here also the value of Rn is nothing but remainder. So now what is the value of remainder here in alternative form? Remainder value is nothing but here h power n by n factorial f power n of a plus theta h. It is the remainder value of alternative form of Taylor's theorem. Okay students, please remember these two formulas, f of b formula and f of a plus h formula. So in the next one about Mclaren's theorem here. So Mclaren's theorem. Mclaren's theorem. Yeah, about Mclaren's theorem. So what is nothing but Mclaren's theorem? So this Mclaren's theorem is also known as special case of Taylor's theorem only. This is known as special case of Taylor's theorem. Special case of Taylor's theorem. We are coming to the statement of Mclaren's theorem. The statement. So if f maps a comma b tends to R is a function such that the first one, f power n minus 1 into x is continuous on 0 comma x closed intervals, and second one, f power n minus 1 into x is derivable on 0 comma x open interval students. So here at first in the theorem, first we wrote here f maps a comma b tends to R here, Here we are taking the limits a comma b as a 0 comma x here in this theorem. A comma b is nothing but 0 comma x. So if it is satisfying the continuous condition and derivable condition, so then there exists one value, theta belongs to 0 comma x such that, f of x is equal to f of 0 plus x into f dash of 0 plus x square by 2 factorial into f double dash of 0, x cubed by 3 factorial into f triple dash of 0, and so on, x power n minus 1 by n minus 1 factorial f power n minus 1 into 0 plus Rn. Okay students. So what is the Mclaren's theorem here? Mclaren's theorem is f of x is equal to f of 0 plus x into f dash of 0 and plus x square by 2 factorial into f double dash of 0 and so on. X power n minus 1 by n minus 1 factorial f power n minus 1 into 0 plus Rn. So here also Rn is known as remainder. Rn is known as remainder. So where the value of Rn is nothing but here the value of Rn is x power n by n factorial f power n of theta x. Okay students, r power n is x power n by n factorial f power n into theta x. Now this remainder is known as Lagrange's form of remainder. Okay, Lagrange's form of remainder. So this about the Taylor's theorem and Mclaren's theorem. Okay, and thank you for watching. On the next section we will go with the problems related to Taylor's theorem and Mclaren's theorem. So please like, share and subscribe our Easy BTech channel students. Thank you for watching.